Hey everyone, it's great to be here today. We're excited to be part of the next top blockchain startup hackathon. So thanks for joining us to learn about Linera and to learn about our price tracks. Let's get into it. And first of all, you might ask, what is Linera? So I founded Linera 2 years ago to solve the big challenges of scalability and latency in Web3. Fast forward today, Linera is a decentralized infrastructure that enables the quickest and the most secure on-chain user interactions, thanks to the concept of microchains. So the idea behind microchains is simple. So we want to run many small chains of blocks in parallel in one set of validators. And we want to allow users and applications to create a new chain for every time there's a particular task. Okay, so for instance, if we wanted to run a game of chess on chain, in the Linera framework, the chess tournament application would spin a new chain for every game. Because a game has only 2 players, so a chain like this would be super lightweight, and that allows the interactions between users to happen with sub-second latency, while retaining the strong properties of security and immutability of a blockchain. We'll get into all the details in a moment, but before that, let me share what we'll be covering today. So after this webinar, you'll have a strong baseline knowledge of Linera and of the price tracks that you can compete for. We'll also ensure that you know how to get started and provide a number of resources to make your submission the best that it can be. So let's get started with introductions. So today you'll hear from me as I provide an introduction to Linera overhaul, and later you'll hear from Christos, one of our software engineers, who will share the price tracks and how to get started with our protocol. Through the hackathon, we have several team members ready to help you out. So namely Andreas and Janito for our engineer team, and Jesse who supports all things developer. We're all looking forward to connecting with you on Discord and beyond. So let's get into it. Nowadays, internet applications are everywhere around us, and most of them are reactive, meaning that they can quickly receive notifications from the server and refresh the data whenever they need in real time. So think about what gaming or instant messaging would be if you had a 10 seconds delay between the screen of each user. That wouldn't be as fun, right? And yet this is pretty much the state of the art in Web3 right now. So in Linera, we want to change that. Our vision is that secure, reactive Web3 should be available to anyone and should be easy to develop for developers. We want, in particular, so if payments occur in Linera, we want the UI of a recipient to see the result of the transfer within a second from the time where the sender initiated the action. And similarly, we want to support the fastest interaction in the case of on-chain games, supporting like this rich interaction, very fast user rewards in the course of the game. Another application that we're very interested in is what I call multi-chain DeFi. So in a world we have lots of parallel chains, we suddenly everything is a dialogue, and we're very interested in enabling the fastest latency in all those interactions. So that's going to enable more efficient arbitrage across chains, obviously within Linera, and in the long term also when Linera interacts with other systems. And that's going to be super important for real-time automated processing of all the information, all the notifications in the system. So what is the state of Web3? Are we reactive and secure yet? Well, not quite, because right now, most L1s and L2, most blockchain infrastructure are prioritizing composability and the transactions per second, TPS, over data latency and the security of clients. And that's visible because they all rely on a single chain with very large blocks, or a few single chains with the large blocks. The problem with large blocks is that once you confirm a transaction, it's still very far from being executed and notified, and the results are not yet visible to the other users. So it's creating a lot of data latency. Hence the 10-second delay I was taking as an example earlier. On the client side, another problem also is that few clients are using a light client. So it means that few of them are actually verifying the data that they get from the API providers. And that's also not very good for data security, and potentially in some use cases, if you want to take automated actions using the data coming from a data provider, it may not be the level of security that works for you. So the solution is to use smaller blocks, but we still want high TPS. So what we're introducing is the idea of microchain. We want an unlimited number of small chains running in parallel, and we're going to give the user a much more central role in this environment. So microchains, to be short, is a new type of user-centric block space with an unlimited number of parallel small chains. How does it work? So we're going to have one set of validators, and the chains are going to communicate with asynchronous cross-test messages. Now, the production of blocks, and this is where it gets really really interesting. So the production of blocks is generally not assumed by validators, but by users themselves. So user wallets are going to be in charge of producing blocks either in their own chains, if they have their, like in a dedicated chain that we call a user chain. And in some cases, they produce blocks in temporary chains that are shared with other users. And so that was the example I was taking of a game of chess. In this case, you would have a temporary chain to play chess with the other player. So Linera is the first decentralized infrastructure based on microchains. It's secured by classic proof of stake, and it's implemented to provide the quickest finality and real-time client synchronization of data while retaining end-to-end security. So concretely, in Linera, the wallets are maintaining full nodes for a subset of microchains that they care about. And that's possible because each microchain is very lightweight. The system is programmable in Rust using the WASM VM. And so if we look at now, how does it solve reactive Web3? Well, every application in Linera is going to be executed on the client side as well as the validator. And in the client side, what's super interesting is that the user wallet now has a full node of the chains that they care about, and in particular, they have the state of the chain. And so the user wallet is going to be able to serve data to the web UI. The web UI is going to be able to subscribe to notifications if the state of a chain is changing, and pull the data when that happens, which is exactly what you want to program a reactive application. As a bonus, and that's relevant for this hackathon, as a bonus, on the client side, we can also use this degree of freedom to run AI models on the client, so on the edge, and that's one of the demos that we propose to be modified and to be generalized or to be experimented with as part of the hackathon. So in conclusion, most existing blockchains prioritize transaction composability over data latency. Microchains is a different point of view, is a different proposal where we organize blocks around accounts and objects, where each account and each object would be typically mapped to their own chain of blocks in Linera. This is super important, super useful for to enable real-time data synchronization and open door for secure reactive Web3 for everyone. And Linera is the first decentralized microchain infrastructure. We're developing everything in Rust and WASM, and we look forward to see your contributions.
Hey everyone, I'm Christos. I'm a software engineer at Linera, and I'm gonna take you over the prize tracks available for this hackathon. So, starting from left to right, we have the best demo for Edge AI. That is smaller models running on the edge, which is the Linera client or wallet. This can be your own demo built from scratch, or you can build on our existing large language model or generative NFT demos. The choice is yours. Next, we have the best UI for a DeFi application. This can be your own DeFi application with a front end, or you can build on the existing autonomous market maker application or the order book app we have available, but it should have a UI or a front end. And finally, we have the best UI for an on-chain game. Again, this can be your own game, or we have an existing hex game that you can use. Now, I'm going to go over these tracks in a bit more depth. However, just because of the time constraints that we have, I'm going to assume that you already know a bit about Linera, how Linera works, the concept of microchains, and so on. I'll be explaining some things, but we don't have time to go into depth on everything today. Having said that, what you can do is you can head over to linera.dev, which is our dev manual, and this has everything about how to get started, how Linera works, how kind of the details that you need to know on the protocol, how to connect to a DevNet, and so on. So this is this is your reference manual for all things Linera. And of course, we have the Discord available where you can ask any questions, and someone on the engineering team will be more than happy to help. So having said all that, let's get started. And I'm going to start in reverse order. So I'm going to start with a game first, because that's kind of builds better. There's a better story there. So let's talk a little bit about the hex game. So this is my IDE that's open on the Linera protocol core repository. And I'm going to head over to examples, hex game. And then on the left, I'm going to open the contract for the hex game. And on the right, the README. I'm just going to head to the top of both. So just as a refresher, Linera applications have two parts. The first is the metered deterministic contract, which you have to pay gas in order to run. This is executed in all of the validators and on the client, in fact. And this is the part that you actually have to pay gas to execute. And this is what mutates the state of your application. Very similar to kind of a smart contract on Ethereum. Next, we have the service, which is the non-metered part of your Linera application. And this is kind of like exposes a read-only view of your application state. So you can query and say, hey, what's the state of my application currently, without having to pay any gas fees. Okay, now that that's out of the way, on the right here, we have the README for the hex game. There's quite a bit here, so I'm not going to get into too many details. However, and by the way, hex, if you don't know, hex is this game where you have this hexagonal grid and you place tiles and you have to go from one side of the other to the board in kind of with a continuous line without your opponent being able to break your line. And so this README is going to take you over how to get started, how to deploy your hex application. And there's quite a bit here because you need to set up some chains. You need to define which players are playing against each other. Owner is kind of like an address on Ethereum. And here, but what is important, I think, is how you actually play the game. So there is no UI, but what you do instead is you use Linera's GraphQL API system. So you can run your client in what's called node service mode, and you do that by just running Linera service. And what this does is, on port 8080, it exposes an HTTP API, which in turn exposes a GraphQL API. And let's just take a look at that real quick. So I'm going to head over to localhost 8080. And here what we can do is we can query all of the applications for a given chain ID. Let's see. To get my chain ID, I'm going to do Linera wallet show. And I'm going to pick up the green chain, which is my default chain here. just going to rerun the service real quick and head back here. And then I'm going to ask for the link and ID for my applications. Okay, so I have two applications deployed. The first is the Hex game. The second is the fungible application, which we'll get into in a bit when we talk about the DeFi application examples. So let's quickly open the Hex game GraphQL ID in another tab. And what we have here is we have the documentation for the Hex game. And there are two root query types. And if you don't know what a root query type is, I would suggest you go and read up on how GraphQL works. The first is the query root, which gives us a read-only view into our application. So it tells you who the winner is, it tells you what the board state is, and so on. And then the second is the mutation root, which is what allows you to actually make a move. So if I wanted to make a move, I would write mutation here, and then make move x1, y3, or whatever. And this would place a tile on coordinates, coordinates 1, 3. And the coordinate system for the Hex game is covered at the top of the Hex game README, kind of here. Okay, cool. So this is how you would interface with a Linera application when you don't have a user interface. And the whole point is to build user interfaces over kind of these raw APIs, or you can build your own game. We'll get into user interfaces in a bit when we switch to talking about the DeFi application examples. However, just to finish up on the game track, personally, I'd be quite excited to see a chess game. I've been wanting to actually write this for a while. I just haven't gotten around to it because we've been doing kind of core protocol development. But if you're interested, there is a chess crate here. crates.io/chess/crates/chess, excuse me. And this is a fast chess library in Rust. It gives you things like legal moves. It gives you things like pieces and boards, and having a chess engine, it's not really an engine because I don't think it generates moves, but having something which enables you to make moves is not trivial in chess. You have things like, you can't castle if there is a square between the king and the rook that's being targeted by another piece, for example. You have a few subtle rules which make it non-trivial, so you can use this crate in conjunction with this React chessboard npm package that I found to build a fully fledged chess app. And if you do that, I'd be really excited to try it out. Okay, so now that we've talked about the game tracks, let's talk about the DeFi track and actually talk about how we can really make front ends at all, because we haven't touched on that. All we've seen is the GraphQL APIs. So let's take a look at the fungible application. So I'm just going to open the README here, and the contract here for the fungible application. Okay, so the fungible application is just an implementation of a fungible token application. It's kind of similar to an ERC20 token under Ethereum. And let's open the GraphQL ID quickly so you can see what APIs it exposes. So I have this open here. Okay, so here under the mutations for the fungible application, we have transfer, where you can transfer a given amount from one account to another, and claim, where you can claim funds that have been sent to you from another account on your chain. Again, the details here are not super important. It's just, just basic APIs that enable you to transfer funds from one account to another. However, what is important is how those are used from the front end. So heading back to my editor here, if you look here under fungible, we have the cargo toml, the manifest of our application, and then we have the source code directory, and at the same height as the source code directory, we have the web frontend directory. And this is just like a React application. Basically, there's nothing clever to it. I'll open the README for that application here. And we built this a while back using npx create React app, I think, or something like that. And kind of what I want to talk about here is just, I think, two things that you need to know in order to get started. So the first is the GraphQL provider. So again, we're consuming GraphQL APIs. And in order to do this, we use the Apollo GraphQL provider, and we set it up such that it points to the node service that I mentioned earlier. So we give it a port, 8080, we give it the application, the chain ID, and the application ID. And also we have this WebSocket client that's used for subscriptions, and specifically in Linera for notifications, which I'll talk about in a little bit. So if you want kind of a boilerplate to get set up, I would just use the fungible the fungible front end, because you have all of this kind of boilerplate set up for you and you don't have to reason about it from the start. Okay, now let's talk about the kind of meat and potatoes of the application, which is app.js here. Now, let me just quickly show you what the front end looks like, because maybe that'll help to make things a little bit clearer. So here we have our Linera Pay application. This is kind of the front. This is what the actual front end looks like for the code we were looking at before. And at the top here, we have the chain ID, which we have to provide explicitly, the application ID, the port, and so on. And the really cool thing about this is that it's reactive. So one of the great things about Linera is that if I send money to you or you send money to me, the moment you send it, in about a second, I'm going to see this update on my front end. And the reason is because we have an end-to-end notification system in the entire network. So how is that actually implemented? Here, what you can see is in our app.js file, along with the actual kind of front-end logic, which is kind of vanilla React, there isn't that much to it, we have these kind of hard-coded GraphQL queries, which correspond to the queries we were looking at earlier here. And we have get balance, get ticker symbol, make payment, but we also have this notification subscription, which allows you to subscribe to notifications for a given chain. And what that means is, the way that this application works, for instance, is that since I am subscribed to my own chain and you send money to my chain, as soon as I receive new money, I'm going to get a notification, which is going to prompt the front end to refresh. So here you see that if, so we have this subscription for the notification subscription, and as soon as we get a new piece of data, we're going to run balance query, which is going to update my balance on the front end. So you can, I mean, the fungible application already has a front end, but you can, we have other examples like the AMM application up here, and the, what's the other one? The matching engine application here, which are a little bit more sophisticated than the fungible application. But I'm really excited to see what kind of cool front ends you guys come up with. So let's talk about the last track, which is the AI track. Now, this is probably the most challenging track in terms of like how difficult it is to implement something interesting, but I wouldn't let that discourage you, for the simple reason that if everyone, like from a game theory perspective, I guess, if everyone doesn't want to work on AI because it's too difficult, then no one's going to submit anything. So, your submission could very well make the top of the available submissions, right? So that's something kind of to think about. But just to show you what kind of an AI application looks like on Linera, we're going to talk about the LLM application, which we wrote a while back. So I'm going to open the README for that real quick. So the LLM application uses a tiny large language model, no pun intended, which is called Linera Stories. It's a 40 million parameter model, a 40 million parameter tiny llama that was made by Andrei Karpathy. And we would like to run larger models, but currently we have some limitations in running models on Linera. So first of all, the Linera applications run in WASM, right? And currently the memory address space that we have is about 4 gigabytes. So intrinsically, we can't really have any models which are bigger than 4 gigabytes. Furthermore, we currently don't have GPU hardware acceleration on the service. We do have CPU acceleration using SIMD, but we don't have any GPU acceleration. So let's take a look at how this kind of works. So I'm going to head to service. And here we have the LLM service. And it just has a model context, where a model context is something, a struct that I've defined. It's just a vector of bytes for the model and a vector of bytes for the tokenizer. And when the service is first instantiated, what's going to happen is we use the runtime API. So the service has a runtime and you can fetch arbitrary URLs. So we fetch the llama stories bytes from Hugging Face, and we also fetch the tokenizer bytes. Now, the great thing here is that a lot of the boilerplate has been done for you, and a lot of the boilerplate was also done for us when we wrote the example application, because we use this amazing library called Candle Rust by the amazing folks at Hugging Face. This is an ML framework for Rust, written in Rust. You can go low level with it, you can go high level with it, but you can run a bunch of different applications, a bunch of different models, and it's just built really well. But it isn't as simple as kind of plug and play, just here's the model, run it. I wish it was, because while I was trying to figure this stuff out, it took a while. But there is a bunch of high-level APIs that do make your life easier. So this is the kind of run model loop, where we take the model bytes, we take the tokenizer, the tokenizer bytes, we encode the prompt that's been given, and then we start to generate tokens until we have reached a certain threshold of tokens that we consider to be sufficient for an output. Now, yeah, this is a little bit more involved than the other examples, but I think it's also very rewarding, and I think it's really exciting that you can get large language models to run on the edge, so that the network can, the deterministic part, the contract can perhaps validate that you're running indeed the correct model. But the fact that you can run it on the edge means that I don't have to send my data to some proprietary GPT model company. I'm not going to name any names here, right? What I can do is I can run an arbitrary model on the edge, and I can just send my data to my own hardware, which I trust because that's where my wallet's running, which is why this is really exciting to me in terms of kind of medical applications, for example, like medical imaging. Maybe you have something on your skin that you want to check, is this something that I should be worried about? And you can just send the image instead of having to send it to some foreign server somewhere or show your doctor. You can just send it to a machine learning model that's running locally. So I think there are some health applications here which are really cool, and of course many others. I'm sure you guys have some good ideas. But yeah, that pretty much covers the three tracks. We covered games and UIs and DeFi applications, and finally AI applications. I'm really excited and curious to see what you guys are going to come up with, and yeah, best of luck.